So, as you may have heard, I'm David Murray from Arista Networks. So I'm a systems engineer based in London. So I'm working with some of you here and many of our Arista customers in the UK. And we are, of course, pleased to be a sponsor of this event and always happy to support the UKNOF community. So today, in the 10 minutes I have available, I'd like to give just a taster, really, of what we can do with next generation telemetry. It's a bit of a buzzword, but going into a little bit of the detail of that and some of the new standards tracks for flow tracking. So just to set the scene quite briefly, I'm sure many of us are familiar with the existing monitoring technologies that perhaps we've been using for 1 or 2 decades. Typically, we're polling our network devices to check their state. So we might be using technologies primarily with SNMP, and that works. But of course, with a polling approach, there can be limitations in terms of the frequency of polling, and then potentially missing valuable data in between those polls. And we are also limited, of course, to what is actually defined in MIBs. So if the information we're looking for is not defined in an SNMP MIB, then naturally it's quite hard to get out using SNMP. So that's the traditional model. And one thing we've been working quite hard on over the past few years at Arista, but of course other networking vendors are doing as well, is a move towards streaming telemetry. So what is state streaming? Well, firstly, it means we can actually serialize state changes within switches and routers out onto our monitoring network in real time. So as soon as an interface, as soon as a state change happens, we can serialize that out onto the wire and into our repository, our monitoring system. So the small example you can see here in the top right-hand side of the screen, maybe if you have an interface flapping with one of your peers, then you could get a notification as soon as that interface goes down, and likewise when it comes back up, we can notify you of that. Traditional polling technologies, we may actually miss that because the interface may be flapping, let's say, between those polling periods. So that's one key benefit. But the other one, of course, I mentioned we're not limited to those MIBs now, so we can actually stream out pretty much any state change of the switch or router. Speaking for Arista's implementation, we actually store all of the network state centrally in a database, and that means it's really easy to stream out in real time. So let's say you want to monitor forwarding tables, and as soon as a route changes or you learn a MAC or a next hop changes, we can stream out exactly what that was and when it happened in real time. So that's great. We've got this fire hose of data, but then how do we actually collate and analyze that? So there are a number of open standards that can be used to do this. So for example, we implement OpenConfig as many other vendors do. So that state set of data can be streamed out, typically using some standards-based transport. So that might be netconf, that might be gRPC. And we can then store that in our repository. So that may be using some clever storage technologies such as HBase and so on. Then once we've got that data, we can put it to other tools for analysis. So just briefly, what are the sort of technologies we might be using to build this with? Well, first we want to store that data. So that's typically in some sort of distributed key value database. So there's a few example technologies I'm showing here: HBase, Cassandra, Prometheus, and so on. At Arista, we have our own telemetry storage product we call CloudVision. And as it happens, we've chosen HBase for the key value database. And then we also need some queuing system to retrieve that stream data. We chose Kafka, but you may also be familiar with technologies such as ActiveMQ, ZeroMQ, RabbitMQ, and so on. On top of that, we need some sort of analytics and visualization. So, that might be technologies such as Spark, Storm, Kibana, and so on. Bear with me. Sorry, I'm getting ahead of myself here. So we've got that technology, and here's a screenshot of an example of what we can do with that. So this is our CloudVision system, which is taking that stream data in and visualizing it for you in a web-based GUI. And the example I'm showing here is flow tracking. So we're actually streaming out flow data in real time. That flow data could be SFlow today, could be IPFix, that sort of technology. And then we can actually visualize that in a topology view where you can dive in for a certain packet flow, right? In this case, this host and destination and TCP flow. And we can visualize that, and we can visualize the packets going back and forth within our environment. So we're getting that rich visibility, but also it's fully historical. So we can actually go back in time and say, you know, this outage that happened at the weekend, what was the flow data at that point in time? So that's a benefit today that we have with telemetry. But there are some challenges with the technologies I mentioned, such as SFlow or IPFix for flow tracking. So yes, we do get some visibility, we do get the statistics, and we can use that for trend analysis, troubleshooting, capacity planning, maybe some accounting and billing. But that data set from SFlow or IPFix is still quite limiting in terms of if we want really rich flow data. So if we want to ask questions like, well, what was the path at a given time for this given flow? We can't guarantee that from SFlow or IPFix, right? Also, we don't get any of that data plane information. So if I have packets traversing my network, ideally, I would like to know for a given flow, for a given packet, what was the hardware state of the switches or routers in the middle, right? What was the traffic class? What was the queue congestion like? What was the latency of the node at the time the packet was forwarded? And that's where we're starting to see some new exciting emerging standards be developed for this sort of flow tracking. And so a little bit of a look to the future of what we are implementing. And of course, other vendors are implementing as a standard. So this is currently with the ITF in draft format for in-band flow analytics. And the idea, you can probably see there's a packet header on the slide here. And really the idea is there's a new standard for defining this sort of in-band telemetry, where we can actually get a much richer data set as to the real data plane state as that packet or frame is forwarded through our network. So in this diagram you can see here, when we hit the start of the network, we have an initiating node, and that initiating node can actually insert the new flow header into the packet body. And so that could either be a copy of the packet, or it could be the real packet itself. Naturally, if you're using a copy of the packet, that means we're not interrupting the data plane path of the actual traffic. And then as that gets forwarded throughout our environment, we can actually continually insert those headers to give all of that real-time information. So for example, timestamps, port utilization, things like port drops, we can actually insert that into the header.
David,
and then
you've got 2 minutes left.
Thank you very much. Once we have that built up through our network, we actually then have that full set of packet headers for the full path of real-time information. And then taking that same state streaming methodology, we can then stream that into some sort of collector. So in the Arista case, it would be CloudVision, but of course, I'm sure there'll be lots of other exciting open source and alternative collection options to come as well. So that's a kind of exciting future technology. So we are working on implementing this draft. Obviously, we're hoping it will be ratified and give you lots of richer information into what's actually happening with your packet flows. That's it from me.